Okay, welcome back to our final day for Activity 100. Let's go over those analysis questions that you were supposed to do for class today. So analysis question number 1 asked you, how does DNA provide evidence about how species are related? So what you should have come up with is that um, DNA molecules contain the informational blueprint for the organism, which is inherited through generations of evolution, meaning you get your DNA from your parents, okay? That DNA is the instruction manual for you. Two species with very similar DNA sequences are more closely related than two species with less similar DNA, meaning your DNA, if you had an identical twin, would be identical. Your DNA to your siblings, if you share the same parents, is probably pretty close. If you are looking at cousins, there are probably a little bit more differences. So the more closer related you are, the more similar your DNA would be. So do you see those big yellow stars? That's the most important part. So therefore, DNA comparisons provide a major line of evidence for how closely related any two species are. You guys, it's the best evidence. You can argue fossils a little bit. Some of that is inference. You can have different opinions about fossils and where they were found and how they go together and what they might look like, but you cannot argue DNA. It is a fact. It is not inference at all. It is the best evidence that you can have for evolution and showing how similar different organisms are based on their instructions. Okay? So that was the answer to number 1. Please make sure you have a really good answer for that. At the very least, copy down what's in between the stars. So go ahead and pause, and when you're ready for number 2, you can move on. Okay. The question for number 2 said, would you expect the DNA of a seahorse to be more like the DNA of a horse or the DNA of a trout? Use evidence from this activity to support your answer. Okay. So here's the thing. To answer this question, I often get a little giggle in class because some students don't realize what a seahorse is. A seahorse is a fish. It gets its name seahorse because of the way that it swims. It looks like it's galloping and it has like the longer face to it. But a seahorse is a fish. It has scales. It has gills. It breathes underwater. It is for sure a fish. Okay. So would I expect its DNA to be more similar to that of a horse or a fish? And so what you should have said is that because the seahorse is a fish, the DNA of a seahorse is much more likely to resemble that of a trout, which is also a fish, than that of a horse, which is a mammal. Mammals would have more differences. So when you look at your chart in this activity, we found sequences from different mammal species are much more similar to one another, like the dog and the whale and the horse, than they are to sequences from other species, like the fish and the iguana and the birds. Okay? So because the seahorse is a fish, its DNA would be more similar to that of a fish. And I just added this phylogenetic tree. Fish and reptiles and mammals, they probably all had a common ancestor, but because they live in different environments, they adapted differently and their DNA has mutated and changed differently. That's your speciation occurring right there, where you have different species. But the point in this activity is that all of the fish would have much more similar DNA than if you compared them to the other classes. Okay, so I would say if I were writing my answer, I would at the very least, copy that top part. Let me see if it'll let me highlight it. You know me, I think it's all important. But at the very least, I would copy that part in. Okay? All right, when you're ready for number 4, go ahead and move on. Number 4 said, the first mammals evolved from a reptilian ancestor 200 million years ago. Explain why it is not accurate to say that humans evolved from lizards. Okay, so a lizard is a reptile, right? And we are mammals. So would you expect them to have a lot of similarities or a lot of differences? You should be, if you look back at your chart, you should be able to tell me that humans do not share a lot of genetic traits with reptiles, okay? We did have a common ancestor, right? So although humans and lizards share a common ancestor, humans did not evolve from lizards at all, okay? The commonly shared ancestor of both humans and lizards has been extinct for hundreds of millions of years. It probably was an early reptile, and it may have been lizard-like, not like lizards today. But in the millions of the years since it became extinct, both the mammals and the reptile lineages have undergone tremendous amounts of diversification. So if you can imagine a tree and the base of the tree is the common ancestor, lizards went one way, right? They are on that reptile branch. Humans are on the mammal branch, and we went a completely different way. So although we have a lot of things in common with them, we share some DNA the same, probably somewhere around, I would have to look up the number, but my guess would be 60, 70% the same, but there's still quite a bit of differences there. In fact, if you look, any mammal alive today evolved from another mammal that's not even here anymore. So like humans evolved from another human-like mammal that went extinct. It's not around anymore. And horses evolved from an earlier horse, but they're not here either. So everything that's alive on the planet today evolved from something that's already extinct. So there's no way to say that humans and lizards, that humans came from lizards. That doesn't make any sense. Humans came from another type of human, and the lizards we have today came from another type of lizard. That common ancestor is millions of years ago, and it's hard to tell what it is because we don't have DNA from the really, really old stuff, because DNA disappears after a certain amount of time. Okay, so we can only compare the living parts, or the living animals that are alive today, and we can look at their DNA and look to see for similarities, right? Okay, I hope that makes sense. That was usually a question that caused a lot of discussion in class, and it makes me sad that we can't have that talk, because I am sure that you have a lot of really great questions. If you have questions, email them to me, and I will try and answer them. If I get a lot of them, I'll post them on the Google Stream so that everyone can see them, because chances are if you're asking a question, someone else wants to know the answer too. Okay? All right. So the only thing you have left to do is I have created an Activity 100 exit ticket. It's not all multiple choice. It's a little bit of writing. I want you to do your best. It is a graded assignment, and it shows to me that you understand how DNA works and how we use DNA for evolution purposes. A lot of kids have asked me about using their stuff. You guys, while you are at home, you are more than welcome to use your notebooks, the online book, the Google Classroom, your parents, siblings. You can talk to each other. I know it's a grade, but I also know that you don't have as many ways to ask for help. So I don't consider that cheating. You are more than welcome to use your resources, and I invite you to do that. It's one of the reasons why I want you to keep a notebook still, even though we are not in class. So as you do that exit ticket, Feel free to use your notes. Feel free to go back and look at anything that you want to go back and look at. And obviously ask me questions. If you need help with anything, I'd be more than happy to help you. Okay? Good luck, and we will look at the dodo bird tomorrow. All right, guys. Thanks. I'll see you tomorrow.